Okay, unit 4, day 8. We're going to do the discriminant. It's called the discriminant of a quadratic. And what it is, it's actually exactly what it sounds like. When you're discriminant, you're discriminating, you're judging without actually getting to know, say a person. If you're discriminating a person, you're just going by what it looks like. But we're going to do that with a function, so it's okay to do to a function. We're going to try to figure out real quick, just get a real quick story without actually finding the solutions. We're going to find out what types of solutions it has, but not really get the details of exactly what it is. So our learning target here is I will be able to use the discriminant to determine what types of solutions a quadratic has, and it'll also tell me more information about what method I should use. So you can also use that to help you. Okay, should I use quadratic formula? If it's going to be, if they're rational, factoring would be better. So if you have rational, I'll just put it up here, rational, factoring might be better. If it's going to be irrational, you could use square roots, but I would go with quadratic formula. So quadratic formula would probably be better. And also if it was, if they were imaginary, you're probably going to go with quadratic formula. And you could still use square roots of quadratic formula in there, but you don't want to factor unless there's rational roots in there. And rational means it can be written as fractions, and which means that they are factorable. So sometimes we don't need the entire answer. Maybe we just want to know what kind of solutions we have, if it has solutions. If it has two imaginary solutions, that means they're not real number solutions. So if we're talking about an application, they don't have zeros. It's one of those that doesn't have zeros. It's that they're imaginary zeros, but they're not real. So that we just want to know, does it have zeros? So the discriminant is actually part of the quadratic formula. If you remember, negative b plus or minus the square root b squared minus 4ac all over 2a. Just a chunk of this is called the discriminant. So this part right here actually can help you determine what kinds of solutions you'll have. So b squared minus 4ac is the part that tells you whether they're rational, irrational, or imaginary. And even if you have one or two solutions, because most time you have two solutions. You have two rational, two irrational, or two imaginary. Sometimes you have one real solution. It could be rational or will be rational, but you can't have one imaginary solution. That's something that we'll learn about later. That can't happen. So you can't have none either, because now that imaginary solutions exist, or we know what imaginary solutions are, we can't say there's no solution. If there's no real solution, that means there's an imaginary solution. So there's a solution of some kind. So the first scenario, the discriminant itself could be negative, it could be 0, it could be positive and a perfect square, or it could be positive and not a perfect square. So these four things will tell you, each one tells you something different. Okay, so the first one, this is a situation where it's going to have a negative discriminant. So if I had b squared minus 4ac, this is the b, that's a, that's c. So it would be b squared, so it would be 2 squared minus 4 times a times c. And I've got 4 minus 16, which is negative 12. What's happening here is this is what's under a radical. So I'm going to have, if I did the entire thing, which you don't have to, you can, this is how much we need to do and then interpret the negative 12. But behind the scenes, what's going on is I've got negative b plus or minus the square root of negative 12, because that's what's under the radical, all over 2 times a. And if I have a negative under the radical, that means when I try to square the negative, I have i's, which means it's imaginary. You'll have two different imaginary, because you're going to add this and then divide by 2, then you're going to subtract this and divide by 2. So you have two different imaginary solutions, but because this is negative, you'll have two imaginary solutions. Okay, so if the discriminant is negative, they don't exist. Okay, they're imaginary. What if the discriminant is 0, like this case here? So I've got b squared, so that'd be 12 squared minus 4 times a times c. So this is 144 minus, and this is actually going to be 144 also, and you get 0. So if I were to do this entire formula, so negative b plus or minus square root of 0 all over 2 times 4. Well, the square root of 0 is 0. If I took negative 12 plus a 0 and divided by 8, I get the exact same answer as if I took negative 12 minus 0 divided by 8. In both cases, you have negative 12 divided by 8. So both cases, you get a single solution. Okay, so this is, you get one solution, but it is going to be rational. So one rational solution, one rational, and it's always going to be real also. So if you get if that is 0, that means you have a real solution that is also rational because it's going to be written as a fraction. It's going to be this over that, which is actually negative b over 2a. You know, kind of funny how that's the vertex of all quadratic functions. But for this one, this vertex happens to be the actual 0 too. So if you get if the discriminant is 0, one rational real solution. If it's negative, you have two imaginary. Now what if it's positive? Okay, so this guy, if it's positive and a perfect square, like this is b squared would be negative 6 squared. Notice I put the negative in parentheses. So b squared minus 4 times a times c. So I get 36 minus, and this would also be 36. No, 32. So 36 minus 32 is 4. 4 is a perfect square. So it's positive 4, and it's a perfect square. What that means is, first off, I can calculate this. I can square root it. You know, up here I couldn't square root it. Here I could square root it, but it's just 0. So this, if I did the whole thing, would be negative 6 minus the square root, or plus minus the square root of 4, all over 2 times 2. When you square root 4, you'd get 2. So if this is a perfect square, you're going to get another rational number here. It's a nice, neat whole number too. So a whole number plus a whole number divided by a whole number, that means it's going to be, these are going to be numbers that you can calculate. Okay, so negative 6 plus 2, well, those I can add together. That'd be 8 divided by 4. And then negative 6 minus 2 would be 4 divided by 4. So these are both numbers. They're both rational because I can divide them, or at least they're fractions. So it would be 2 and 1. So these are, when this is positive and a perfect square, you can square root it and you get nice, neat answers. So you have 2 real, but also rational solutions. Which means this actually, if it's rational, if they're both rational, you could have factored this. Okay, same thing up here. You got one rational, you could factor that. That would have been, if you wanted to actually solve it, you could have factored it. I use quadratic formula to actually do it, but you know, keeping in mind this, everything to the left of those lines is what I need to see for your work today, unless it asks you to actually solve it. This is just showing you what's happening and why. Now, what if it's positive and not a perfect square? Well, that means on this step, you can't square root it, so it's a radical. And when you take a whole number plus a radical, you can't do it. So it's going to be irrational. So this guy here, so keep in mind, it just means I can't square root that. So b squared, so it'd be negative 4 in parentheses, b squared minus 4 times a times c. So we got 16 minus, and let's see, that'd be negative 24. So this is positive 40, but it's not a perfect square, which means when I plug it into the square root up here, I can't square root it. So I'm going to get, there are 2 real solutions, but they're irrational because they have radicals in them. So these are 4 things to know here. Okay, so if it's negative, imaginary, 2 imaginary. If it's 0, 1 rational real solution. If it's positive and a perfect square, it's going to be 2 real rational solutions. If it's positive but not a perfect square, it's going to be 2 real but irrational solutions. Okay. So predict the type and number of solutions, and then we're going to go ahead and solve it. So this first guy here, I'm just going to use the discriminant to predict. So b squared minus 4 times a times c. So this would be 64 minus, and that's negative 144. So it'd be 208. So first off, that is positive. So it means I can square root it, and if I did plus and minus, if I add a positive number, then subtract a positive number, I'm going to get two different solutions. So it's going to be two solutions. It's positive, so they're going to be real. But can I square root 208? 208 is not a perfect square, so it's going to be irrational. So two irrational solutions. Now if I actually want to solve it, because it says go ahead and solve and see what you get, I'm going to go very quick because this, in fact, I'm going to pause this and write it down. If you want to try it yourself, put in quadratic formula, however you want to do that. Okay, so when I simplified it, I got 208 under the radical because that was already there. And 208, when I factored it down, there were two pairs of 2's. So I did 208. See, I can do 4 and 26. Let's see. Now that ain't right. How do I do this again? Oh, that's 8. Yep. And this would be 2 and 13. This would be 2, 2, and 2. So we got two pairs of 2's. So I can pull two 2's out, which is a 4, with a 13 left under the radical. Since all of these were divisible by 4, divide them all by 4, I get this. The important part is, if I take negative 2 plus the square root of 13, that's irrational. It's some weird decimal. And if I take it minus the square root of 13, I get a different answer. That's a weird decimal. Okay. I failed to point this out, but the reason why I chose quadratic formula is because I predicted two irrational solutions. Irrational, you don't want to try to factor. It's not going to be factorable. So quadratic formula is going to be the easiest way of doing it. This guy up here, 2x squared plus x, bring the 28 over. So now do the discriminant. So b squared, that'd be 1 squared minus 4 times a times c. I can tell right off the bat this is going to be a big negative number. Okay, so we got negative 223. So 1 minus all this is negative 223. So that means I'm going to have, since this is negative, when I try to square root that, I'd have imaginary. So I have two imaginary solutions. When you have imaginary solutions, the quadratic formula is the best one to use. So negative b plus or minus the square root of 223, because I already got all of what's underneath there, all over 2 times 2. I'm sorry, negative 223. So negative 1 plus or minus, and 223, nothing comes out of that, so it'd be I radical 223 over 4. Okay, this guy here, 2x squared plus x minus 28. Looks very familiar, right? This is a negative. Here's a positive, so we're bringing it over, it is a minus now. So I'll have b squared minus 4 c. And this would be 1 minus, and this is going to be a negative 224, which would be 225. So that is positive. That's positive, and it is a perfect square. Okay, if you square root 225, you get 15. So it being a perfect square means these are going to be 2. They're going to be real because I can square root that. But since this is a perfect square, they're going to be rational, which means factoring actually would work on this one. So 2x squared plus x minus 28 equals 0. Let's see, so 2x and x. Do some guessing and checking here. Let's see, I'll do minus 7 plus 4. So that'd be an 8 minus 1. That's what I want. Yep. So x equals, if I switch this sign, it'd be 7 halves, and this will be negative 4. Okay. One more. Let's see. So this guy. So b squared minus 4 times a times c. So it'd be 36 minus, and this is 36. It equals 0. That means I have one solution. It's real because I can square root that. And it's got to be rational too, because anytime you have one solution, it's rational. So this guy here, you could do, actually square roots would probably be easiest, because that means if this is true, that means this is a perfect square trinomial. So this would be x plus 3 squared. You think of it as complete the square too. Now, if you did factoring, you get the same thing, you get x plus 3 times x plus 3. If you did quadratic formula, you got the same answer. So it's not that you have to do square roots on this one, but, and then y square root, you get x plus 3 equals 0, so x equals negative 3. So down here, you do not have to solve. We just want to choose the best method. What method is probably going to be best? So, b squared, negative 5 squared minus 4 times a times c, 25 minus negative 24, that's 49. So it's positive and it's a perfect square. That means we'd have two real rational. So I would use factoring. Don't have to use factoring, you could use quadratic form if you want, but I'm saying factoring, it is factorable, we should say it that way. This one here, if I bring the 8 over, subtract the 8 over, it would be 6x squared plus 0x minus 108. Just so I can get an a, b, and c, I put a 0 in here. So b squared minus 4 times a times c. So it would be 0 minus, this is going to be a big old negative, so 24 times negative 108. Negative 2592, which is positive, but that is not a perfect square. So there's going to be two real, but they're going to be irrational. So on that one, since it'd be irrational, I'd use quadratic formula. Okay, now try these two out. Pause the video, try them out. I'm going to write the answers down here. I want you to just quiz yourself. See if you can figure out what the discriminant is and what's one of the best forms. Okay, so this guy here, I got negative 4 for a discriminant. So negative 4 means if I tried to square root that, I get imaginary. So it's going to be 2 imaginary. So yeah, on this one, I would probably just do quadratic formula. Quadratic formula. And this guy here, I got 36, it's positive, which means I could square root, or it can be square rooted, but it's also a perfect square, which means you're going to have two real, and they're going to be rational. So this one, factoring would probably be fastest, or at least it is factorable. You could do quadratic formula then after that, but this would probably be my number 1 and my number 2.